Hello, everyone. This is a review of our AP Calculus final exam. So, question one. So, this is a little bit faster to review for us because we don't really have any class left. So, this video format also is helpful for you to troubleshoot if you had any sort of mistakes in the exam. So, let's get into it. Question one. Determine the point on the curve at which the tangent line is parallel to this line. So first, we need to find the slope of this line. If you write it in this format, then the slope would be -2, right? And because these two lines need to be parallel, their slope needs to be the same. There you go. So we need the y prime to be equal to -2. So we have y prime, we can find it from here. Derivative of y, so e raised to x, the same thing, e raised to x. Derivative of 4x is 4. So minus e raised to x plus 4 is -2, minus e raised to x is -6. E raised to x is 6, and then x would be ln of 6. So that's the x value. When we ask for a point, right, find the x and y. So y would be f of that point, ln of 6. So we're going to plug in the ln of 6 in here. That would be 2 minus e raised to ln of 6 plus 4 times ln of 6. So this is one of the properties of ln, right? So e raised to any logarithm with the same base would be the argument of that logarithm. So we have 6 here, we have 2. The y value becomes -4 plus 4 ln of 6. There you go. That's question one. Let's go to question two. Determine the slope of the tangent line to this ellipse. So we have this equation, we have x and y. It's a good idea to use implicit differentiation, right? So derivative of 5x2 would be 10x. Then we have this xy, so we're going to use the product rule, right? Derivative of x would be 6y, and then derivative of y would be -6x, but y prime, right? Don't forget the y prime. The same for this term. So that would be 10y, but then y prime. So we're going to factor for y prime, right? And then y prime becomes this 6y minus 10x over 10y minus 6. 10y minus 6x. At this point, with the coordinate of x being 1 and the y being -1, so we're going to substitute that for x and y in here. We're going to get a value of 1. There you go. All right, question 3. We have this logarithmic function. It says at what point is the tangent to this curve perpendicular to this line. So first, let's find the slope of the line. We're going to write it in this format. So this -1/2 is a slope of the line. For two lines to be perpendicular, we need the product of their slopes to be -1, right? There you go. So the M2, the slope of the other line would be -1/M1 that we found here, -1/2. So this would be 2. Basically, the tangent line to this curve, which would be f prime, needs to be 2. So we can find the f prime from here, right? We take the derivative of logarithm. That would be derivative of the argument, which is 4 minus 2x over the same argument times ln of the base, right? And for this term, the derivative is 2. So this needs to be equal to 2. There you go. So we have this equation to be equal to 0. The numerator, right, has the root of x equals 2, but we have some conditions here, so make sure we check those. So here in the denominator, we cannot have that being equal to 0. resulting in two roots, x0 and x4. And because the root that we found, right, 2 is not any of these two, so we're happy with this x equals to 2. Again, we're asking for the point, so make sure you find both x and y. So y value would be f of that 2. We're going to plug that in here, right? If we do, we're going to get logarithm of 4 in base of 3 plus 4. So that's the point that we were looking for. All right, next question. 4, determine whether this function x, ln of x, has any local minimum, local maximum, or inflection point within its domain. So let's first find the domain. The domain here, there's no limitation on this x, but on this x, argument of ln must be positive and not 0. So there it is, that's the domain. Now, to find local minimum and maximum, we need to find critical points, f prime. We're going to use the product rule in here, right? We use the product rule. So that would be derivative of this x, which is ln of x, right? Derivative of x is 1. And then plus x times derivative of ln, which is 1 over x. So this is our f prime. F prime equal to 0 to find the critical points. That means ln of x plus 1 equal to 0 or ln of x equal to minus 1. We're going to use the definition of logarithm, and that will give us x being equal to the base, which is e raised to minus 1. That would be 1 over e, right? So that is our critical point. Remember, 0, right? Because it's not part of a domain and is not part of the domain of f prime, right? Is not really a critical point because it's not part of it. So the only critical point is 1 over e. So this is f prime. In order to find the sign of this f prime here, we're just going to plug in the values in the f prime, right? Any value is smaller than 1 over e, right, would be negative value larger than this one will make the whole thing negative. Any value larger than that, right? Remember, ln of 1 over e is minus 1, right? So anything larger than that will result in a larger value than that, which means the sign would be positive, right? So we have decreasing, increasing trend. That means we have a local minimum at this point. In order to find the inflection points, right, we're going to find f double prime. So we're going to take the derivative of this equation now, right? ln of x is derivative is 1 over x. The domain of f double prime, x larger than 0, right? 0 is not acceptable, right? That's the only limitation on this expression, but because we must go with positive values, that's a domain of f, right? So that will result in domain of f double prime being positive values. In order to find any values that have f double prime being 0, we don't have anything, there is no solution. And if you look at the sign of f double prime, it's always positive, right? So basically we have always the curvature upward for the function, and because there is no change in the sign of that curvature, we don't have any inflection points. All right, question 5, find the absolute extreme values of this function. So we have the interval. We need to find the critical points and also compare it to the values at these. So critical points, f prime, we're going to use the product rule. Derivative of e raised to minus x is minus e raised to minus x, right? And then we write this, cosine plus sine, plus, we're going to write this one now, and then derivative of this expression. Derivative of cosine is minus sine, and derivative of sine is cosine. We're going to factor e minus x in here. So we have minus cosine, minus sine, and then minus sine here, cosine here. We can cancel these cosines, and then we'll end up with minus 2 sine, then e minus x. So critical points, again, f prime doesn't exist or f prime equal to 0. There is no limitation in on this f prime. And in terms of the roots of f prime being equal to 0, so we have two factors, e raised to minus x equal to 0, which is 1e raised to x, which can never be 0, right? E raised to minus x basically doesn't have any roots. Or sine of x equal to 0, right? Which means x is k pi, right? These are the 0 values. In this interval, the only value that we have is 0, right? So there you go. We have three values to compare to find the absolute extreme values. 0, and then our intervals minus pi over 2, pi over 2. So we're going to plug in the 0. That would be e raised to 0, which is 1. Cosine of 0, which is 1. Sine of 0 is 1, so we get a 1 here. We get minus pi over 2. We're going to plug that in here. We're going to get minus e raised to pi over 2. And pi over 2, when we plug it in, we're going to get 1 over e raised to pi over 2. So we have this negative value, which is clearly our minimum, right? And our maximum is going to be between these two. This is 1 over e raised to this value, right? And this is 2.7 raised to, let's say, this pi, which is 1.5. So that would be 1 over this value. So that means this is larger. So we have our maximum to be 1, our minimum to be this value. Maximum occurs at point 0, right? And then minimum, this value occurs at this point minus pi over 2. There you go. That's question 5. Let's go to 6. So an optimization problem. We have a company running a utility cable from point A in here onshore to an installation on an island at point B. So this area is underwater. This is land. This is underwater, right? The island B is 6 kilometer from this point C onshore, and point A is 9 kilometers from point C. So it costs $400 per kilometer to run cable on land if we were doing it from A to C, or 500 kilometers anywhere underwater, right? So it says what distance from A, right, should the company start running the cable if they wish to minimize the cost of the project? So the cost would be that $400, right, on land in here, and then times $500 underwater, right? So let's say if you're running it all the way from A to C, right, we're not going to save a lot of money, and then we go from here, right? That would be more costly. We can also do from maybe here to here, right? Do not run anything on land. But there may be a combination that will give us the optimized value, right? So if we run cable from A to this intermediate point, and let's call this distance x, right? So this would be 9 minus x. So this length of cable is on land, so 9 minus x times 400, and then y value here, right, times 500, and we'll try to minimize this. So we have x and y. We need to find one of them in terms of the other. So y here, right, can easily be found from this triangle. Y squared is 6 squared plus x squared, right? There you go. So we're going to substitute the y in there. So px is our px is our function, 9 minus x times 400, and then 500 times this y, which is based on x. As we discussed, x could be 0. That means we're running the cable all the way from here to here, and then like that, or 9 from here to here, right? Or anything in between. So we're trying to find that optimal value. So we know what to do. we'll find the critical point P prime, right? The derivative in here is minus 400. And for this term would be 2x right there. We have 500 and 2 a square root, right, of the same thing. P prime equal to 0. There you go. This is equal to 400. If we simplify this, that would be 5 over 4x equals to the square root. If you raise both to the exponent of 2, 25, 16x2 is x2 plus 36. That means 9/16 of x2 is 36. So x would be this value, right? Which is 8. So we have 8. Don't forget, we also have 0 and 9 as possibilities. So we're going to substitute the p in these values, right? In our px function that we have in here. If we substitute 8, our critical point, we get the cost of $5,400. If we plug in 0, we get the cost of $6,600. If we plug in 9, we get 5,408, right? As you can see, very, very close to that. But this will give us the minimum amount, right? So that would be only 1 kilometer, right, east of this A, right? If we went with this 9, right, we're only paying $8 more, right? But then the entire cable could be underwater. So in reality, right, if you were doing this as an engineering project, the project manager would probably choose this one, right? Because then you don't have to come up with two different methods, right? Land and water. You can only go with water, but you're paying more. However, in our course, we only care about the math part of it. All right, does that make sense? So this is it, the minimum value, 1 kilometer east of A. All right, question 7. So a 1.6 meter tall woman walks away from a 10-meter high lamppost. So this is our lamppost, 10 meter. This is the woman, 1.6, right? Walking away, so going this way at a rate of 1 meter per second. So let's come up with some variables. This is 10 meters. This is 1.6. So we can come up with this one, maybe X, Y, or A, B. Doesn't really matter what variables you use, right? So if you use Y here and X here for the shadow of the woman, right? So the woman rate of change, right, or speed is 1 meter per second. That's dy dt. And we're trying to find how fast is the length of her shadow. X is changing, right? dx dt. So we're trying to find dx dt at the point when y, right, is 15. Does it make sense? So this is an easy problem, right, of similar triangles. The large triangle ABC, right, is similar to this smaller triangle DBE, right, because of two angles are equal. This angle A and D are 90 degrees, and then this angle is common between the two. So if you write the ratio of similarity, x plus y divided by this 10, right, is equal to x divided by 1.6. There you go. So now we can find an equation between x and y. So 1.6 times x plus y equals 10x. So now we have 1.6x, 1.6y, 10x. That would be 1.6y equals to 8.4x. So x is 1.6 over 8.4y or 4 over 21. So we're looking for dx dt. If we take the derivative of this equation, right? dx dt is dy dt times this constant, 421. dy dt, we have 1 meter per second. So this dx dt is 421 meter per second, right? There you go. Question 8. So we have a cubic polynomial, third degree. It is increasing on these intervals, so minus infinity to -1 is increasing. That means f prime is positive. And 2 to infinity as well, increasing. But then decreasing between -1 and 2. There you go. So with this, we have increasing trend, decreasing. So we have a local maximum here, meaning the f prime of this -1 is 0. The same goes for the other critical point 2, right? Decreasing, increasing. So we have a local minimum of f prime of 2 being 0. Remember, f prime of local minimum or maximum is either 0 or not defined. But because we have a polynomial, we don't have any non-defined situation, right? There you go. So we have our cubic polynomial, a x cubed, b x squared, cx plus d. F prime would be 3ax2, 2bx plus c. So if we plug in f prime values, right, these two in here, we only have two equations, but three unknowns, A, B, C. Sure, we got rid of D, but we still have three unknowns. We can't really do anything with it, right? So it's a better idea if we write f prime, right, in this format. This is the format. We know our f prime, right? It's a quadratic equation. It has two roots. We have the roots, -1 and 2, right? So whenever we had a quadratic equation with two roots, R and P, we can write it in the form of x minus r, x minus p, the roots, right? And then times the a, which is the lead coefficient, right? So now our f prime, if you write it in that form, a, which we don't know what it is, and remember, it's different with this a, right? So this is a uppercase. The roots are -1, so that would be x minus -1, and 2, x minus 2, there you go. So we can write it in this format, right? So we have f prime, one of them in this format, the other one in this format. They're equal to each other. So now we can find a relationship between this ABC that is ultimately we're looking for in here, right? Based on this uppercase A. So if we compare these two, A would be uppercase A would be 3 times this lowercase a, right? So that's the relationship between them. And here we have minus a equals to 2b. So b is minus a over 2. And then c is equal to minus 2a. There you go. We can also find or use the other pieces of information given to us. It says g, I think we use f, doesn't really matter, right? So f of -1 is 13, f of 2 is -14. We're going to use these values in our fx, right? If we do, f of -1 is 13. So we're going to find an equation between a, b, c, d in here and here, the second one, right? And now that we have these two equations, right, we can use these all of these A, B, C values, right, based on the uppercase A. So, for example, here I have minus A, so I'm going to use A third, there you go, B minus A over 2, and then minus C minus 2A right there, and D, right, equal to 13. The same goes for the other, the second equation there, 14, right? So if these two equations, we're going to use these definition of ABC based on uppercase A. And once we do, we have two equations that only have two unknowns, A and D, right? So we have two equations, two unknowns. With this kind of trick, right, we reduce our equation into this two, which is easy to solve. We can find A to be 6 and D to be 6 as well. Okay, both we get 6, great. And now we have A, right? We can go back to this equation, a star, to find A, B, C, right? Let me find them here. That's A, B, C. So our polynomial is going to be 2x cubed minus 3x squared minus 12x plus 6. There you go. Find all unit vectors perpendicular to the vector 1, 2, 3. And make equal angles with I and J. All right, so let's assume looking for this unit vector. Let's call it V. So vector V, A, B, C are its X, Y, and Z components we're trying to find. So it says they make equal angles with I and J. If you start with V dot I, right? So that is magnitude of V, magnitude of I, cosine of the angle theta, right? Let's say between this I and V. We know the magnitude of V because this is a unit vector. It is 1. Magnitude of I is also 1. So V dot I becomes this cosine of theta. If you do the same for V dot J, we have magnitude of V, magnitude of J, and then cosine of another angle. Let's call it gamma, right? So magnitude of V again is 1, magnitude of J is 1. So this reduces to this cosine. And the question says this vector makes equal angles, right, with these unit vectors. So that means this angle theta and gamma are equal, right? From this, we can conclude that V dot I equals V dot J, right? So we have that, and now if we use the dot vector product in vector form, so here we used it in the magnitude and angle form, and now in coordinate form. So V is A, B, C, I is 1, 0, 0. And here, A, B, C, J is 0, 1, 0, right? So with unit vector, we know how to find the dot product. That would be A on this side, right? And then 0 and 0. So basically A plus 0 plus 0 on this side, that would be 0 plus B plus 0. So we found A equals B, right? So we found one component of this vector, right? And the other piece of information that we have, it says this vector is perpendicular to this vector 1, 2, 3, right? So from that, we have our vector A, B, C dot 1, 2, 3. It's perpendicular. That means their dot product are 0. So here, because we said A equals B, right, we can just substitute that with A. There you go. So now this dot product becomes A and then plus 2A plus 3C equal to 0. This is 3A plus 3C equal to 0. So here we can find this relationship between A and C, right? So A is minus C. So we found all these components of vector V that we're looking for based on A, right? So our vector, I can write it in that form. So our vector V would be A, and minus A, right? Does it make sense? So this is also A for us. And the last piece of information that we have is says this vector is actually a unit vector. So its magnitude must be 1. So here, magnitude of V must be 1. And from there, we can plug in the components there. So this would be A squared plus A squared plus minus A squared, which is the same thing, equals to 1. So this is 3A squared, right, equals 1. And from here we can find our A, which is 1 over a square root of 3, right, either minus or plus. You can also rationalize this. So minus plus a square root of 3 over 3. There you go. So the vector V, its components are, so either minus plus, right? So A is a square root of 3 over 3. And then the second component is also the same thing. The last component, right, would be as a different sign compared to the other one, right? There you go. So this is our vector B. There you go. Last question, question 10. So we have this diagram and we have some information. So it says this is a square with side lengths of 20. Great. So this, sorry, 24, 24, 24. It says M is the midpoint. So this would be 12. This is 12, right? What else? N is situated in this ratio. So that's 1 to 2. Right? So if this is 8, that would be, sorry, if this is 24, this would be 8. This is 16, right? So we have all of these sides, and now it says we have this P intersection point, and so we have some relationships here. We have AP equals M AM. There you go. They're collinear. And on the other side, we have BP equals N, BN. They're also collinear. So we're going to find M and N, right? So we have all of this information. If we start with the vector format, right, with what we had, so we had AP. So if you start with that AP in here, we have vector AP equals M vector AM, right? So vector AP, we don't have a lot of information about it, but vector AM, we do, right? So this is vector AM, right? And we have the coordinates. So the coordinates for this point M, if you start looking at this as a coordinate system, right? If you're looking at this as a coordinate system, something like that, right? Then we can see that this vector could be described, right, from this point, if we call this point origin 0 and 0, right, by this coordinate. So the coordinates here, 24 and then 12, right? That's vector AM. So vector AM, I can describe it by 24 and 12. Don't forget the M here, so we have that M. And also the same thing for BP, if you use the same. So BP first is N times BN, right? So all we need is find a vector representation of Bn. So Bn is this vector going all the way there, right? This vector in the x direction, right, is going 16 in the negative direction. So that's negative 16. And 24 in the y direction, right? There you go. So we describe these vectors, right, in our coordinate system here. And so all we need now is find a relationship between these two vectors that we have, basically our AP and BP. So these two, if we can relate them somehow, right, we can find these unknowns M and N. So what is a good relationship there? So we have AP here, and we also have BP. So if you look at it, AP plus PB gives us this vector AB that we have it, right? So if I write this relationship that I just mentioned, AP plus PB, right? That's equal to vector AB. Does it make sense? There you go. So we have that. And now if I describe these in terms of vectors, vector AP, right? So vector AP, we have it from here. It's vector AP. That's M times 24 and 12. And then we have vector PB. So vector PB is the negative of vector BP, right? So I'm going to use a negative sign here, right? Does it make sense? And then times this vector representation that we have, minus 16 and 24. So this equals to AB, and AB is an easy vector for us. We have its information is 24 in X direction and 0 in Y direction. There you go. So now we have a relationship between these two. If we write the x and y components, right, on each side. So the x component will give us 24m minus, so that would be plus 16n equals 24. And y component gives me 12m minus 24n equals 0, right? There you go. So from this system of equation, I can find n and m. So it's easier to start with that one, right? If you start with this one, we have basically, so 12m equals 24n, or m equals 2n, right? So that's what we have here. And if we just plug this in the first one, right, you are all set. So if we use that in this one, this would be 24, and instead of n, we're going to use 2n plus 16n equals 24. This is 224, 48, right? And 16. So we have 48 and 16. That would be what, 64? So 64n equals 24. N is 24 divided by 64, which is 3/8. So there you go, that's n, and from here we can also find m, which is twice of that. So that would be 3/4. There you go. So this is the last question from our final exam.